that is not transmitting nerve signals. What happens when the cell is stimulated? A stimulus changes the permeability of the cell membrane to sodium and potassium ions. This alters the distribution of charge in the cell body, and if the change is great enough, it triggers a signal, called an action potential, that moves down the axon. How does the action potential move along the axon? Voltage-gated channels in the membrane open and close depending on voltage changes across the membrane. When no nerve signals are being transmitted, these channels are closed. A stimulus causes voltage-gated sodium channels to open, and sodium ions rush into the cell. The cell becomes positive on the inside and negative on the outside. Very quickly, the sodium channels close while voltage-gated potassium channels open, allowing potassium ions to rapidly diffuse out. The cell returns to being positive on the outside and negative on the inside, and the potassium channels close. Meanwhile, the sodium ions inside the cell have diffused to adjacent areas, causing a slight change in the polarity of the membrane ahead of the action potential. This change in polarity causes the voltage-gated sodium channels along this part of the membrane to open. Again, sodium ions rush in and the action potential spreads to the adjacent part of the neuron. In this way, the action potential travels down the neuron like a wave. In the wake of the action potential, potassium leaves the cell, restoring the negative charge inside the neuron. Meanwhile, the sodium-potassium pump has been shuttling sodium ions out and potassium ions in, re-establishing the resting potential distribution of sodium and potassium ions. Let's look at another action potential as it moves along the membrane. This time we will measure the voltage changes that occur in one spot along the membrane. A slight change in polarity causes the voltage-gated sodium channels to open. Sodium ions rush in, causing a reversal in membrane polarity. Sodium channels close and potassium channels open. As potassium ions rush out, the membrane returns to being negative on the inside. The sodium-potassium pump then restores the balance of ions present at resting potential.